Hi, welcome students. My name is Jesse, and today we're going to learn about ionic bonds and compounds. Today, Andrew, Destiny, and myself are going to teach you what they are and how they work. Before we get into our demonstrations, we need to learn about them, and that's where Andrew comes in.
Hi, my name is Andrew, and today we are going to learn how ionic bonds and compounds work. First, all we need to know is the difference of the two. An ionic bond is a process of two atoms sharing various electrons. An ionic compound is the product created after the two have bonded. Ionic compound is a compound composed. Consider the reaction between a sodium atom and a chlorine atom. The sodium atom has a single valence electron that it can easily lose. If the sodium atom loses its valence electron, it achieves the stable electron configuration of neon. The chlorine atom has 7 valence electrons that can easily gain one electron. If a chlorine atom gains a valence electron, it can achieve the stable electrons configuration of argon. When sodium and chlorine react to the form of a compound, the sodium atom transfers its one valence electron to the chlorine atom. Thus, sodium and chlorine atoms combine in a 1:1 ratio, and both ions are stable. Although they are composed of ions and ionic compounds, the total positive charge of the cations equals to the total negative charge of the anions. Ionic bonds have the opposite charges and attract one another by means of electrostatic forces. The electrostatic forces that hold ions together in ionic compounds, sodium, chlorine, chloride, provide a simple example of how ionic bonds are formed. Therefore, the chemical formulas of an ionic compound refers to a ratio known as the formula unit. A formula unit is the lowest whole number ratio of ions and ionic compound. Chemical formulas. A chemical formula shows the numbers of atoms of each element in the smallest representative unit of the substance. For example, NaCl is the chemical formula of sodium chloride. Ionic compounds do not exist as a single discrete unit, but as collections of positively and negatively charged ions arranged in repeating patterns.
Hi, my name is Destiny, and today I'm going to show a demonstration on how ionic bonds are used through the ionic bonding of sodium and chlorine to form salt. The salt that people use for food usually is sodium chloride. Sodium is a metal and chlorine is a nonmetal. In order for metals to become a stable octet, it must give up its valence electrons. A nonmetal has to receive new electrons to complete its valence shell to be a stable octet. So metals and nonmetals join to fulfill each other's needs. A sodium atom has one valence electron to get rid of, while a chlorine atom has 7 valence electrons and will need to receive one more electron to complete its valence shell. There are 2 electrons in the first electron shell and 8 electrons in the second and third shells, and that's how ionic bonds and compounds are formed.
Hi again, my name is Jesse, and I'm going to show you how even though sometimes something may look like bonding, it's really not. If you have an air-filled balloon and rub it against someone's hair, it would look as if there's bonding, but it isn't, because they discharge upon contact with each other. Ionic bonds are due to permanent ions due to electronegativity. Sometimes this means an atom will lose an electron, forming a positive charge, or will gain an electron, forming a negative charge, in order to have 8 electrons. So the positive ions will bond to the negative and vice versa, without loss of charge due to the need for 8 valence electrons. With static electricity, it is unstable, and electricity will form a current to spread out and move to a lower potential. Then both sides will be neutral charge, and there will be no bonding. Ionic bonds and compounds sure are interesting, and thank you for paying attention, and bye.